Dear students, carbon is an unique element. The uniqueness stems from its ability to form catenation, that is self-bonding into long chains and rings, and its tetravalency, forming four stable covalent bonds, which allow it to create an enormous diversity of stable compounds, including long chains, branch chains, rings, and polymers, resulting in the vast field of organic chemistry and the complex. The reason behind the availability of large number of carbon compound is tetravalency. Carbon has four valence electrons, allowing it to form four stable covalent bonds with other atoms, including other carbon atoms and elements like hydrogen, oxygen, and nitrogen. Next is catenation. Carbon's ability to form strong, stable bonds with itself is exceptional. This self-linking can create long straight chains, branch chains, and ring. Hydrocarbons. A hydrocarbon is an organic compound composed solely of hydrogen and carbon atoms. These compounds are fundamental building blocks of organic chemistry and are crucial for energy production and material manufacturing. Found in natural resources like petroleum and coal, hydrocarbons serve as fuels such as LPG, CNG, and gasoline, lubricants, and raw materials for producing polymers and other organic chemicals. We can classify hydrocarbons as saturated hydrocarbon and unsaturated hydrocarbon. A saturated hydrocarbon, like an alkane, is an organic compound containing only carbon and hydrogen atoms, where all carbon-carbon bonds are single bonds. These hydrocarbons are considered saturated because each carbon atom is bonded to the maximum possible number of hydrogen atoms, meaning no additional atoms can be added without breaking a bond. The general formula for alkanes is CnH2n plus 2, and examples include methane, the chemical formula CH4, ethane, chemical formula C2H6, propane, chemical formula C3H8, butane, pentane, etc. Unsaturated hydrocarbons. An unsaturated hydrocarbon is an organic compound containing only carbon and hydrogen atoms with at least one carbon-carbon double or triple bond. This presence of multiple bonds means they contain fewer hydrogen atoms than a saturated hydrocarbon with the same number of carbons and are generally more reactive. Common example includes alkenes with double bonds like ethene and alkynes with triple bond like ethyne. Isomerism. Isomerism is a chemical phenomenon where different compounds share the same molecular formula but have distinct structural arrangement of atoms or spatial configurations, leading to different physical and chemical properties. These differing compounds are called isomers and they exhibit isomerism. Isomers can exhibit distinct physical and chemical properties even though they have the same number and types of atoms. Here you can see some isomers. The normal butane and isobutane with the same chemical formula C4H10. There are two isomers in this chemical formula, normal butane and isobutane. And for pentane, the formula C5H12 has three isomers. They are normal pentane, isopentane and neopentane. Functional groups. In chemistry, a functional group is a specific group of atoms within a molecule that determines its characteristics, chemical properties, and reactivity. These groups are responsible for a molecule's unique chemical reactions and are classified together, meaning compounds with the same functional group share similar behaviors regardless of larger molecules composition. First one, the halides. Halides is a functional group in organic chemistry, involves a halogen atom. You might know halogens: fluorine, chlorine, bromine, or iodine, covalently bonded to a carbon atom, forming a carbon halogen bond. This functional group, also known as haloalkane or alkyl halide, is represented by the general formula Rx, where R is an alkyl group and X represent the halogen. Here there is an example of halogen: chloromethane and bromoethane. The next functional group is alcohol. It is the hydroxyl group represented as OH. This group consists of one oxygen atom covalently bonded to one hydrogen atom, and it is this hydroxyl group bonded to carbon atom that gives alcohol. Their characteristics, properties are different from others. You can see the examples of alcohol here: CH3OH, that is methanol, and C2H5OH, that is ethanol. You can say methyl alcohol and ethyl alcohol. The next functional group is aldehyde. It is a group represented as CHO, which consists of a carboxyl group, that is C double bond O, bonded to a hydrogen atom, and a generic R group, that is a alkyl. This CHO group is essentially a carbonyl group where one of the carbon bond is occupied by a hydrogen atom. So here you can see the example, the structure of an aldehyde. That is here, that aldehyde ends with Al, methanol, which has one carbon atom, and the second example is ethanol, which has two. The next functional group is carboxylic acid. It is also called carboxyl group, which is written as COOH. This group consists of carbonyl group, that is CO, bonded to hydroxyl group, that is OH, on the same carbon atom. So here you can see the example of carboxylic acid. The carboxylic acid ends with oic acid, OIC. You can pronounce that oic acid. Here I am showing two examples. One is methanoic acid, other one is ethanoic acid. So usually meth represent one carbon atom and eth represent two carbon atom. So the last one is ketone. It is the functional group of a ketone is a carbonyl group where the carbonyl carbon is bonded to two other carbon atoms, represented as RCOR. This structure defines the characteristics, chemical properties of ketones, setting them apart from other carbonyl compounds like aldehydes, which have a carbonyl group bonded to at least one hydrogen atom. So here there is one example of a ketone, that is acetone. It is also known as propanone because the ketone ends with -one. So there are three carbon atoms. Three prop represent to three. So the name is propanone. The common name is acetone. Students, after watching this video, please go through the book and try to answer the questions in the book. There are two questions given in the slide. These are important questions. Please try to answer these questions. These type of questions were helpful to understand the concept well. Thank you for watching the video. I will publish some more videos from this chapter. And bye bye.